So we could talk about continuous from the left. Continuous from the left basically involves a one-sided limit from the left. And continuous from the right basically involves a one-sided limit from the right. And continuous on interval means you're continuous at every point inside. So when you look at this graph, we can see that there's like we can see that there is, I guess, three interesting points here. I would say x equal to -2 is one of the interesting points. I would say x is equal to 1 is another interesting point. And I would say x equal to 3 is an interesting point. So at x equal to -2, we have a removable discontinuity. At x equal to 1, we have a jump. At x equal to 3, we have an infinite. I don't know if I feel comfortable saying this. I know I said this on the video. I almost don't want to write this. I almost kind of want to come over here and scratch out this, make that a round bracket. I wanted to capture the idea of one-sided continuity, but technically the definition of continuity, the limit has to exist from both sides. So, so I think if I ask you a question, I'll just say, is it continuous from the left or is it continuous from the right? But this type of thing is a little bit trickier because you really need the two one-sided limits to both exist. I hope that makes sense to you. So I want you to try this classwork right here. And I tried to make this classwork a bit clearer than the previous example that I did there by saying, by really emphasizing, okay, determine where the graph is continuous from the left, but not from the right. So when I say, but not from the right, that means it has to be continuous from both directions. So that's trying to remove any ambiguity. Okay. So why don't you guys try all three of these and then answer this last question as well. Just take a few moments to try that. And when you're done, you can let me know. I just want to make sure you understand what I'm saying. So like normally we would say all these points right here, these are all continuous, right? All these points are continuous, but I'm not going to write all these points for number 2A because these are both continuous from the left and from the right. I just want to know which points are continuous from the left, but not from the right. So it's not going to be all of these guys. It's going to be like a handful of points potentially. All right, think about it for a few minutes and then we'll go over it together. Okay, let's talk about it. When I look, well, we have a couple of points. Okay. The first thing I want to say is that to me, it looks like something interesting happens at -8, something interesting happens at -2, something interesting happens at 6. When I look at -8, it's not continuous from the left and it's not continuous from the right. So at x equal to -8, it's nothing. When I look at x equal to -2, when I come from the left, it's continuous because it looks like it's going to 3 and the function value actually is equal to 3. So this guy is continuous from the left. But if I come from the right side, it's not continuous because it's going off to positive infinity. So from the right, it goes off to positive infinity. So I think this answer is definitely correct. If I come from the, if I'm at 6, if I come from the left, it's not continuous. But if I come from the right, it actually is continuous. So actually, when I want to determine where the graph is continuous from the right, but not from the left, that's actually going to be equal to x equal to 6. Okay. I had one student suggest that maybe x equal to 10 was a potential point. This guy is continuous from the left, but it's also continuous from the right. So it violates the but not continuous from the right part. I hope that makes sense to you. Reagan, I see in the chat box, you put -2, 3. And I think you were trying to give me the X and Y coordinates. But a lot of times when they say like where, they want to know the X coordinate. So you can just write the X coordinate. You don't have to write the Y coordinate. Because when I see your answer, it looks like you're trying to say X is, the answer is -2 and 3. But that's not what you mean. You mean -2, 3, like that point. So usually we just write the X value. So let's talk about this last guy. Oh, I forgot that there had a typo on this. This came up in class yesterday, but then I forgot to tell you guys. So this is the intervals of continuity. Over the summer, I was shooting all these videos, and there's like a little bit of a lag between my video shooting and my note editing, and concavity is something we studied later. I was probably making a concavity video and I made a typo there. So we want to know which intervals this guy is continuous. So my first question for you is, how many intervals do you think I'm going to write? Is it going to be 1 interval, 2 intervals, 3 intervals, or 4 intervals, 5 intervals? Does anyone have any feeling? If you don't, that's fine. If you do, you could. Leah says 4. I think that's a good guess, Leah. Audrey says 3. Not a bad guess. Like Leah's guess slightly better. Let me explain why. Let's say I try to draw this graph with my pen and want to count how many times do I not have to lift my pen off the paper. So if I come this way, oops. Here's one segment, but then to continue drawing the graph, I have to lift my pen off the paper. Okay, here's a second segment. But then to continue drawing this graph, I have to lift my pen off the paper. Here's a third segment. And then I gotta lift my pen off the paper. And then here's the last segment. So like Leah said, I think there's gonna be 4 intervals. And I think I'm gonna write those intervals as follows. This is gonna go from -infinity to -8. I'm gonna use a round bracket. I'm going to put a union, and the next interval is going to go from -8 to 2, -2. And here I'm also going to use a round bracket. This is the situation I was talking about where you need the limit to exist from both sides and to be equal. So in this case, it's not. Okay, then my next one is going to go from -2 to 6. And then my last one's going to go from 6 to positive infinity. Okay. So my interpretation of the continuous, I'm not including these boundary points, even though it's continuous from one direction. You can tell me if your book thinks something differently when you try the homework. But I think if I'm working strictly from the definition, I would have open circles there. All right.
Question.
Okay. Yes, question.
So for the union -8 and -2, why wouldn't -2 be a bracket instead of parentheses?
So, to be honest, I'm a little bit like undecided if I want to write a bracket or a parentheses. When I look at the definition of continuity at the very beginning, this limit here is a two-sided limit, right? You have to come from the left and the right. So that's why I did not put a square bracket to include it. Because I think from the definition, it has to be continuous from both directions. And I feel comfortable asking you a one-sided limit question like this, where I specify it's one-sided. But if I ask you where it's continuous, I'm unclear whether I need to include this or not. So I decided to leave it off. But if you start getting homework questions that are wrong, you should include it, and then you can get back to me and tell me that the book disagrees with me. So I just
Okay.
kind of agonize over that choice.
Thank you, Professor.
You're welcome.